Now, solution to engineering mechanics by S. Timosinko, D.H. Young, J.B. Rao, Sukumar Pati. Both Timosinko and H. Young are from Stanford. J.B. Rao is the director, and Dr. Sukumar Pati is now a professor. Now, let me go back to the statement of the problem. Now, problem set 2.3, a solution 2.22. What we'll be dealing with equilibrium of concurrent forces, right? The statement of the problem is like this: an electric light fixture means to fix an electric light. An electric light fixture of weight Q is equal to 178 Newton. This is your electric light bulb. Its weight is vertically downward. Q, that is 178 Newton, is supported as shown in the figure. As shown, from B to A is a string, from B to C is a string, and this is also another string along which the weight Q is acting downward. Determine the tensile force S1. Determine the tensile force S1 and S2 in the wires BA and BC. If their angles of inclination are as shown. This is a wire BA, and this is the point of suspension B, so the tensile force S1 is away from the point. Since this is also a wire, BC is also a wire, the tensile force S2 is also away from the point. This angle is given as 60, this angle is given as 45, and the value of Q is given as 178 Newton. So what is given? Very simple. What is given? Q is equal to 178 Newton, S1 to be found out, S to be found out. Now, BA from B to A is a wire, and BC is also another wire. Therefore, the tensile force S1, which is along a wire, will be away from the point of suspension. So S1, S2. Similarly, S2 also. So S1, S2 are away from the point B. Now, I draw a free body diagram about the point B. Right? Means here, if you draw a line, let me show you like this. Here, if you draw a horizontal line like this, that is same thing as this x dash. And if you draw a vertical line like this, that is your y dash. Now, since this angle is 60, so this will be 60. That is what I have shown here, alternate angle. And then again, since this is 45, this angle will also be 45, alternate angle. That is what I have shown here in the free body diagram at the point B. And this is your Q acting downward, that is equal to 178 Newton given. So now this is 60, this is y-axis, this is x-axis, this is 60. Therefore, this much will be 90 minus 60, that is equal to 15 degree. 60, 90 minus 60, that will be equal to 30 degree. So this whole angle from here to here will be 45 plus 30, that is 75. Then this is 60, from here to here is 90, then this whole angle will be 90 plus 60, that is equal to 150 degree. Similarly, this is 45, so I am left with 45 here. This is 90, so 90 plus 45 is from here to is 135. Because I will be using the Lami's theorem, so I am finding out. So, since S1, S2 and Q are concurrent at point B, applying Lami's theorem, Q over Q over sine of this angle. This is 75. 45 plus 30 sine 75 is equal to S1 over this angle, sine 35, will be equal to S2 over this opposite angle, sine 150. Now, so let us consider this one first and cross multiply to find out S1. Then consider this with this, cross multiply and find S2, as simple as that. So, so I am considering the first one, Q over sine 75 is 1 over sine 35, cross multiplying S1 is sine 135 sine 75 into Q. Q is given as 175. Use a scientific calculator, put the value of this Q, it comes out to be 130.305 Newton. Again, if you consider Q over sine 75 is S2 over sine 150 and cross multiply, sine S2 comes out to be sine 150 was in the denominator, comes here in the numerator. Put value of this and value of this, Q as 178, that is given Newton. So use a scientific calculator, this comes out to be 92.139 Newton. Now let me quickly give you the principle of equilibrium. Equilibrium does not mean at rest, right? Sigma F is equal to 0. For linear equilibrium, sigma tau is equal to 0 for rotational equilibrium, tau torque, F force. Means if a body is moving at constant speed, then also say it is in equilibrium. If it is at rest, then also you say it is also at equilibrium. Means the net force is acting on it is 0. Similarly, if a fan is rotating at constant angular velocity means there is no acceleration, angular acceleration, then that is also in equilibrium. If a ceiling fan is at rest, that is also equilibrium if it is rotating at constant angular velocity, omega constant. Therefore, d omega by dt, which is equal to alpha, constant, derivative of a constant 0, so angular acceleration is 0. So, a ceiling fan not rotating at rest is in equilibrium. If it is rotating at constant angular velocity, then also it is in equilibrium. Similarly, if a body is at rest, it is in equilibrium. If it is moving with constant speed, then also it is in equilibrium. Right? So don't confuse the word equilibrium as rest. Right? It can be equilibrium of rest, it can be equilibrium of motion. Now, the principle of equilibrium, two-force principle, means if there are two forces acting on a body and the body is in equilibrium, then if a body is in equilibrium under the action of two forces, then one must be equal and opposite and collinear with the other. Then only it will cancel. If there is a force to this side, there must be an equal and opposite force exactly to the opposite side, so they cancel, so the net force on it is 0. That is sigma F is equal to 0. That is sigma F is equal to 0. Now, similarly, the three-force principle. If a body is in equilibrium under the action of three forces, then any one must be equal, opposite, and collinear with the resultant of the other two. What do you mean by this? Suppose there are three forces. This is a body. Three forces are acting, one to this side, one to this side. Then the resultant of these two, that is this one, must be equal, opposite, and collinear with the third one. Then this will cancel with the resultant of these two. So net F will be equal to 0. That is what it wants to convey. Now, similarly, the force principle. Similarly, the resultant of any, if four forces are acting on a body and the body is in equilibrium, the resultant of any two must be equal, opposite, and collinear with the resultant of the other two. What do you mean by this? Suppose there are four forces. 1, 2, the resultant of these two will be this. and there are two more. This is F1, this is F2, and there are four acting at this point, and suppose the resultant of the other two, that is F3 and F4, must be equal and opposite to this. Then only it will cancel. So the sigma F will be equal to 0. That is what it want to convey. Thank you.